Hi, Tom. Lift and Shift Foundation. I'm surprised. It's a crazy day here. I say that a lot, but today really it's been a crazy 2 days. My internet has been off. I live here in New York City, and I work from home, so I rely on my home internet. And something happened a block away. I have no idea, but it's been 2 days without the internet, and my internet just came on an hour ago. I was not expecting to be here. I was not expecting to chat. I was not expecting to follow up on, do anything that we were creating last week. But we're here, and I'm live, and this will probably be short because I've been under the gun to try to get things done. And as you're gonna see here, I think right there in a minute. Yeah, there we go. Right there. I'm gonna quickly cover some of the things that we did last week. And before I cover it, we were adapting our robot, our 3D printer, our Makeblock Ranger robot, because we have this thing called Battle of the Bots. And this is the tank that we're trying to mod. We're trying to hack this tank. I'll get into the hack in a minute. But today is actually unique because this is the first time that I'm sharing live shots of the 3D printer, and I realized that this is a good opportunity for me to have a chat about the 3D printer that we use and the software we use, and the reasons behind those choices, because it was put into how we best introduce people, veterans, their kids, their families, everyone, to the world of 3D modeling, 3D printing. Is some of the things that sound really hard, really complicated, and you get into this and you realize it's not. It's not that hard at all. But I put a lot of effort into breaking this stuff down so that anyone can do it. So that I can do it with my kids. You can come here and join us and do this with your kids. So I'm gonna quickly, while this print is running. I'm not going to explain too much about the print right now, but I'm going to just talk about the printer and talk about the software we use. So the printer that you can see right there is actually a Creality. Sorry, I'm always going to mispronounce that name. Creality. I have an Ender 3 Pro. Yeah, Ender 3 Pro. There's several models, and I've hacked it a little bit, so that I think it's actually an Ender 3 version 2. But in any case, it's at the Lift and Shift Foundation, I did not want us to be very, very high tech, very, very expensive. I wanted a printer that was easily accessible to families, to budget conscious, veteran families, people who didn't want to spend a lot of money. If they decided they wanted to get into 3D printing. And I'm not advocating for Creality right now. I'm not saying that they're a sponsor. I'm not saying that we have any benefit from them. I'm not trying to push their products. But when I looked into buying a 3D printer when the pandemic started, for myself, for my home, this is my apartment. This was rated one of the easily in the top 10 as far as printers are concerned, but I think it was rated 1 or 2 at the time, and like I said, in 2019. So I went with something that was good for me to get started in my home. I work with other scientists and other researchers and engineers and things, and there's a variety of other printers out there. So for example, there's a lab down the street I work part-time in over the weekends, and they just bought a massive Ultimaker S5. I think the final paycheck was like the final bill was 15 grand, more than 50, over 15 grand. It was pretty expensive. So this printer, when I bought it, was, and I'll can I zoom in on the printer? Yeah. So that printer right there, when I bought it, was about it was under $300, and I think that was a feature. That was a good thing about it. I've done a few things to it. I've changed a few things. The printer did not come with a glass bed, so the surface that you see that object on is shiny and it's glass. it does not come like that. It did not come like that. That was a, I don't know, a $20-$30 upgrade for it. I upgraded the motherboard so that it was very 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 quiet now. It was much louder when I first bought it, and no, not a big deal. But I actually moved that into my bedroom. I can sleep next to that. It's on a shelf literally on a shelf next to my bed. I can sleep next to it. It doesn't bother me at all. So after those modifications, what else can I say about it? I don't know. The build envelope, you'll see. Well, I'll stick my hands in there when I go over there to get that print. That print is almost done, and it's almost done because, like I said, my internet came on maybe an hour ago, and that brings me to the software that we use to make the things that go on there. The software we use here at the Lift and Shift Foundation is more than just this, because we have a design team that has access to a more complicated stuff. But I'm going to switch to our window here of something that we designed last week and get into the project that we are working on today, which is a follow-up from last week, a continuation. This is Tinkercad, and Autodesk makes this. The Autodesk makes a series of software, AutoCAD, which is very, very, very popular and very, very expensive software. We on our design team can dive into Fusion 360, and I've been using that a little bit more. There's a lot of other CAD software out there for designing things. There's SolidWorks I sometimes use in a lab. There's SketchUp. There's, oh my gosh, there's so many other, and like I said, I'm not promoting any specific product, but I try to use Tinkercad specifically for everything I share publicly and with groups, because Tinkercad is free, and I'm looking for a word. Oh my gosh, it's been a crazy hour or so, but I'm the learning curve to picking up Tinkercad is very low. It's not a very steep or a big struggle to start designing things in Tinkercad. So here on Twitch, last year I was very very big into coming up with designs and models and things that I could do, so I could show the individual buttons in the toolbox and things. All the cool features that they really put into Tinkercad, because it's a great piece of software for learning how to design in a virtual space like this. But lately I've been moving on to more intermediate, I guess is the word I'll use. It's less beginner, like here's how I use this stuff, and more of like okay, we're going to open it and we're going to use some tools that we see here on the side without much explanation into it, and hopefully you can follow along. If you can't, there's a ton of YouTube videos out there. If you want more, hopefully people will hop into the chat and join the conversation, and I will eventually start answering those questions. But I for the sake of content and for anybody starting to catch on, I would prefer to actually just build things and make things cool, because I like to build stuff. So as my keyboard is slow to respond here, I'm coming back to the me, and this comes back to kind of our project. So I was in a race to get this started. I had no internet, so I'm barefoot. I'm in my apartment. I don't know if I mentioned that or not. And like I said, my internet was off. I did not expect to be here. But at 7 o'clock or about there, when my internet turned on, I first had access to Tinkercad. So we designed this. Actually, I'm going to switch back to it. We designed this last week. And through the week, this week, I was going to print it so that we could actually work with it right here on my work desk. And without the internet for about 2 days. Oh, you see my print's done. My print's done. See it right there? There it goes. It's sliding up. So, perfect timing, because I'm about to discuss that. I couldn't log into Tinkercad and get that file. I couldn't log into Tinkercad and download this file right here. So I was stuck all week until, an hour ago. So what ended up happening was, an hour ago I downloaded this file. I was able to log in finally. I downloaded this file, put it in my slicer. I use Cura, which is also very, very, very low tech. It's free, and it's probably a little more complicated than Tinkercad, and I don't give enough attention to it when I teach people how to do the 3D modeling part, because there's some complications with the hardware and things that because this is all virtual, and this is all over Twitch and YouTube. So there's things that would really be helpful to see in person, and I do those through workshops occasionally, where we design things like dog tags with groups of veterans, and we will design the dog tags and we will print them out, and I will go through the process of slicing them and all of that other stuff and share this screen just like that. But this print took 45 minutes to print, so by the time I downloaded it and did all the slicing and got it into my printer and got it to go, it was like 7:30ish. Yeah, 7:30ish, and that gave me just enough time to set up, to introduce this and go talk through the discussion, talk through how all of this happened, how like I said, my week has been kind of crazy. So this was perfect timing, and what I'm about to do right now is I'm gonna walk over into my bedroom, grab that part off. So what's happening right now is that glass bed. I'm gonna continue talking because, as you can see, that glass bed, the glass plate that is binder clipped to the bottom there, to the printer, has a heated bottom, so the heat helps the plastic stick to it, and right now it's cooling, and the glass and the plastic will cool at different rates. So and maybe you were a kid in science class when you learned that things expand and contract when they get hot. So what's going on right now is the glass and that plastic plate are contracting at different rates because they're cooling off, and as they contract at different rates, they will cease to stick together, and I'll be able, in a few minutes, when they're completely cooled out to room temperature, I'll be able to go walk over. Hey dude, hi, how you doing? I'll be able to go over and just pull it right off the print, off the plate, and I'm going to try that right now. So what you're going to see is me wander over into my bedroom and try to grab that plate. I'll be right back. So, if you happen to catch my big fat fingers on there trying to get this thing off of the glass plate, what you may have seen is it's on there. It's on there very good. It's on there really well. I'll try to use some better English, but that's part of the design of the printer, and part of the reason why I switched to a glass plate there. The glass plate heats up, and it provides a surface that is much more adhesive for the melted plastic that's coming out of the printer. So it's stuck on there right now, and it was still like 50 degrees Celsius. That's like, I don't know, like 110, 120 degrees Fahrenheit for those of us using the imperial system. But it will cool to room temperature, which is half that roughly. Here, I think my apartment's a little warm today. It's probably like 27, 28 degrees. So we're going to give it another minute or two to let it cool off, and I'll hopefully people will catch the difference that I can just walk over and pull it off once it cools, and that's one of my favorite parts about using the glass bed. And the material is called PLA. That's an acronym for polylactic acid. It's a very friendly plastic. It's recyclable. I don't know. I don't think it's biodegradable, so you can't just chuck it in your compost. But I will say that a lot of 3D print plastic people. It's called a filament. So a lot of people who make the filament that goes into this 3D printer will recycle their plastic. So that plastic right there, that PLA right there, is actually made from a veteran-owned company called 3D Fuel, and it's a special version of their. I think their brand is called Workday, and they kind of are one of our sponsors. So I'm just gonna say that now and say that they give us a tremendous discount on the rolls of plastic that we use, and I tremendously appreciate them, especially as another veteran. I know how hard it is to build things and to run things, and the challenges that come along with that. So I'm super psyched that that they exist, A, and B, that they help us introduce 3D printing to so many other people. So I appreciate them, and they'll never know. I'm not like tagging them in anything, at least not today. But anyway, so the rolls of plastic that we buy from them are made from 30% recycled PLA. So they grind up all the old PLA and melt it down with all the new PLA, and at least 30% of it is the old stuff. So it's cool. I dig it. I feel like that's doing our part to take care of the environment by not wasting so much. Yeah. The company the company name is 3D Fuel. And I think it's just 3D-fuel.com. Yeah, cool dudes. They offer actually some really cool filaments and things. Some are infused with hemp or coffee or I want to say glass. There were a few really cool options, but they have a massive variety of colors and a few different types of material. There's also I don't know all the materials they offer, but there's a PETG, PETG. It's a polyethyl triglycerol. It's a big long chemical name. It's basically the same material that you get out of your water bottles. So when you go buy a water bottle from the store, that water bottle's made out of a PETG type material. And we actually have some of that too. It's also 30% recycled. I don't use it too often. I'm not quite sure why, but anyway. So there's a little bit of background about the compound, the material, and this project, and specifically, I'm going to go back to the screen right here. This in Tinkercad we put together last week, and this is meant to hack the battery box in our Ranger robot. So here we go. I'm going to come back. I've got this massive battery box. It takes 6 AA's to run this robot, and it's loose right now because I'm going to fasten that plate to this, and we're going to move the battery box. And I'm going to while we're still waiting to see if that's going to cool, or I'm going to struggle to get it off. This is the robot that we use for Battle of the Bots, and it's made by Makeblock. Yeah, you can see the name right there, Makeblock. It's a cool place, and this is just one of the robots that we use. This is the bigger one. I dig it because it's tank, but the battery box goes way under here, and the batteries fly out all the time. These robots are just like crashing and banging and knocking each other out, and when they go tumble and roll and to do all the cool stuff, the batteries fly out. And because it's way under there, the battery box mounts all the way under there, and you can't get to it, you can't see it, you can't get the batteries in and out. So we've been doing this Battle of the Bots now since November. We started the pilot trial type thing, and it's been one of the biggest drawbacks to the live events is that once the batteries come out, it takes minutes to take this box off, and sometimes these risers off, and get to the batteries to be able to put them back in. It's annoying. It's awkward, but we like that the batteries fly out because it's hysterical. It really just shows that you're kicking the other team's butt when you knock their batteries out. So we've gone through a few workshops of kind of like, how do we do this? How do we make it fun? How do we keep the batteries flying out? And instead of redesigning the battery box, we decided we wanted to move the battery box to the back. So what we want to do is pull the battery box out and try to move it right here to the back. That way the batteries are more accessible and we can get them in and out. And last week I went through this kind of discussion and analysis of my hypothesis that I think moving the batteries to the back might make them harder to fly out. Physics, torque, rotational axis, all the math nobody wants to talk about. But it's just my hunch, my hypothesis as an engineer, is that the batteries may be harder to knock out if we make this move. But the batteries will be easier to put back because they'll be accessible. So I'm psyched to see this and psyched to do this. And this is where I'm going to come back now to that plate. So that plate is meant to fasten this battery box, or basically extend this battery box bolt holes in a perpendicular pattern, so that we can kind of move it to the side. And you can see it there. It's just made out of some standard gray PLA that is recycled. And well, I'm going to show you here on the battery box. Hey, hi, as I flashing through screens. So this battery box has these two holes, one here and one here. So you'll see the pins are meant to go in these spots to kind of hold the battery box this way instead of this way. And then we can bolt the battery box to one of the original holes right here. And I think this is going to work out fun. I think it'll be, after this stream, it'll be a lot of fun. With the time constraint I had with having no internet and jumping through hoops to get online, I couldn't set up an extra camera so you can see my desk, my workbench here. So I'm going to have to hold this stuff up and show you here as I go through the assembly and the kind of like putting these pieces together. And I'm already prepped with a bunch of other things in case I did this wrong last week. I realized I could have made the bolt holes just a tiny bit bigger, and I was very unprecise, inaccurate, maybe, possibly. I was kind of eyeballing measurements here and there with this digital caliper right here. So it's possible I was off by a little bit, and we're going to find out whether or not I have to kind of do some ugly hacking, which happens occasionally when I need to do things fast, or whether I got this good just by like eyeballing things up. And on that note, I'm going to go back to that right there. So hopefully you catch me sneaking in there and grabbing this thing. So that was a ton easier to grab off the plate, right? There was no struggle, no frustration, no friction. It just kind of slipped right off. That's what I've been talking about. It's this surface and that glass surface cool at or contract at different rates because they're different materials as they're cooling. So as they both contract, one contracts faster than the other one. Their surfaces disconnect basically, so it ends up just sitting on it, not attached anymore. And that's a weird call I got, but hold on, let me make that go away. Dun dun dun. Crazy day. So here's our plate, and I'm gonna show you both sides of it because I rarely show the 3D printing part of what we do. I do a lot of the Tinkercad stuff. But here's the plate, and you can see this actually looks kind of shiny, right? There's a couple lines here and there where it looks like maybe it didn't stick the way it was supposed to on the glass bed. Actually, you can see shapes from other prints, and somebody is very persistent. You can see shapes from other prints here where I use an adhesive. I actually use hairspray to help stick to the glass. Some 3D print people use glue sticks, like elementary school kind of glue sticks. They cover the bottom. That is super annoying. I don't know if that's coming through on the screen because it's shaking the whole table, but somebody really needs to get a hold of me, and it's just across the street. But I don't see the building on fire, so we'll just ignore it for now. But so you can see the glare. That's a fairly smooth surface, right? And that's cool because it's on the glass, so the glass actually makes it smooth. And the other surface, which is the top surface, doesn't have anything pressed up against it, so it's not quite as smooth. And that's how these type of 3D printers work. So just want to highlight that, point that out. It doesn't always look super smooth and perfect. There's some settings in Cura that you can use to do that, to kind of tweak things if you're going to make, I don't know, production grade. But like I said, this I printed at low quality because I wanted to get it off the printer in time to actually fasten these parts together. So that's I opted for the rougher looking features so that we can get this moving. And on that note, we should see that this lines up. I will do it this way. So the holes line up. You can see my fat finger right in there. So I'm gonna drop some screws in here. And ooh, just barely not big enough. Let's see, did I make that so that they could thread right in? It is barely threading right in. Dun dun dun. That's one. Screw number 2. Yes, these are lining up perfect. I did a decent job. Okay, so I designed this so that we could actually use bolts and nuts on the back, but that threaded in perfect. And that's the cool part about the plastic, is that metal screws will just thread in if you have the dimensions right. So I'm just going to slip on these nuts right here just because I may not open this box with this robot again for a few minutes. Couple days maybe. And we're going to just tighten up the screws right there. So now we've got our plate. And the cool part is this screw is exposed on both sides. So now we can add the screw on the robot. This lines up wonderful. Great. We did a great job last week. And I say we because, well, I feel like it was a team effort. So the thing is, we want to slip this right there on that bracket because there's a threaded hole right there where the screws will fit in. So the goal is to slip this right here. And it actually works. Look at that. Oh, it's just I gotta twist it and tweak it just a tiny bit to get it to line up on the bolt holes. And it's going to be hard for you to see this, but this is looking excellent. And if I flip this over, you'll get a better view. So right there is the bolt hole. It's going to hold the battery in, and this looks good. This looks really good, yeah. So, like that, I can slip this bolt in and do some adjustment. I'm going to grab the same screw that I had set aside. Oh, nope, maybe not. What did I do wrong there in putting screws out for myself? Oh, here it is. Right there. And this tool comes with the robot. It's a lifesaver. And there we go. It is attaching. It is going in. That is awesome. I dig it. So we have created our first hack for the Ranger robot that Makeblock makes. And as you can see now, we have the battery mounted on the back. So now I can slip the batteries in and just plug in the wire, just like that. We'll do some routing with the wire, maybe a zip tie or something. Slip the battery wire that way. But now I'm going to see how easy it is to put the batteries in. Battery, 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 you guessed it, battery, dun dun dun, last, battery. Batteries are in. Batteries are in. That was easy. That took so little time. This was taking 5 minutes or so before. Easily 5 minutes. Because I would have to unbolt these bolts here to take this plate off so that I could even get close to the some of the batteries, but it was just a nightmare. So that was so much easier. And we're powered on. Our big guy here is good. That was super, super easy. I dig it. I'm excited. This is going to make Battle of the Bots much more fun. And now that I know that I can do this, I can print another one of those plates for our other Ranger robot, and we can have them do some cool stuff. Like faster battles, bigger battles, all the fun stuff that we do. So the only thing I didn't really cover today was Kira and the slicer. I kind of showed off the 3D printer, which is, again, it's a Creality. Oh my gosh, Ender 3 is the name of the actual name of the printer. Ender 3 Pro was the one I bought, but there are a few different versions on the market. I think they're up to like an Ender 3 version 2 something. Anyway, it's a good starter printer. It's a good, under a $300 printer if you want to experiment, try to get into 3D printing. I love it. It's my favorite. I have two here, and the other one is actually right here next to my desk. I use it for my day job when I'm not here doing fun nonprofit stuff, and it's bigger. It's the same parts, the same product line, but it's more industrial type. So the Ender that you see up there is cooler from let me go back to it, from a plug and play kind of version or aspect, so that you can kind of see it's smaller than the one I have, but that means there's less assembly and setup, and that one came out of the box ready to rock and roll, and I was printing very, very, very quickly with it. Whereas this other one I have here, it's called a CR10, is the second one I have. There was not, I don't want to say it's harder, but from my experience having 4 of them, it was more difficult to calibrate and set up. And I think it's a much larger printer, so I think that has something to do with it. The Ender up there is smaller. It's about 200 millimeters by 200 millimeters, so 7-8 inches square. A build envelope by 9 inches tall. So it's limited in size, but it makes up for it in ease of use as far as I was concerned, and I didn't really need any engineering skills to build it. It kind of just came with some screws and bolts and things to put together. The instructions weren't bad, and I was probably up and printing within an hour. So that's it. And of course, Tinkercad. I'll just switch here again back to the Tinkercad view. Tinkercad is free. You can go to tinkercad.com and sign up for an account, and you can learn how to make your own 3D models. You can export them as an STL file. You can go download a program called Cura from the internet. It's CURA, and you can in half a day with that printer showing up, you'll be printing your own designs, and it's I promise it's not hard. We're going to do some more workshops with hacking this robot, though. So in the future, more of this this steam engine type content is going to get into some of the fun things about Battle of the Bots. So we're going to be designing, oh gosh, everything from new arenas and new hardware for the robots to new applications and programs. Sometimes we'll get into some of the coding behind how the robots do what they do. It's cool because these are some of the things that we work on. Actually, our design member, we have a design team that helps me construct all of this stuff, and behind the scenes we've had quite a few chats on how we build new events, because the sumo battle is fun, but we want to up the game. We want to make it even more fun and bring new things. So, well, I think you'll see more than just the Ranger tank in the future, and you'll probably see other challenges, not just the sumo battle that we normally do. And we'll be bringing some of that design here. I'll be sharing what we do with the design team, because the design team tries to meet again like weekly. It didn't happen this week because I had no internet. But that's it. I try to make these like 40 minutes ish. That's been my schedule. That's usually when my time runs out. So I'm actually stalling because I realize that I'm at 36 minutes, and if I don't do this for a whole 40 minutes, I feel like I'm ripping people off. But it's cool. We followed up with last week's project. It turned out better than I thought. I actually had a soldering iron. I was going to poke some holes in the plastic if it didn't fit the way I needed it to fit, but it worked out well. And I don't recommend that because it releases plastic melting, toxic chemical type stuff. But I have some fans set up right here actually, and like I said, I was already prepared for that kind of shenanigans. Anyway, that's it. I think I'm done.